Hello, in this video I'm going to talk about constructors in C# and what they are and when we use them. Constructors are special functions that we use to create objects for us. They are used to create the object and they're used to initialize the object. So what does it mean to initialize an object? It just means to set the variables in that object to their initial states. So let's take an example here. Here's a class called a player, and the player has two variables in it, a string, which contains the name of the player, and we will set it to link here, like a Legend of Zelda reference. And the player has a variable that says how much health the player has, so there's 100 health. Now, let's say that this player has a fairly complicated inventory, and that's what this function is here. It says void setup inventory, and then in the comment here it says lots of code. So imagine that this function here has lots and lots of code. And so when we create the player, we need to set up the inventory. How do we do that? Well, this is a great place to use a constructor. In fact, all objects, you should always define a constructor for your objects, and if you don't define a constructor for your objects, you're going to get a default constructor for you. Otherwise, you won't be able to create the object. So let's imagine what that would look like. Here's the constructor for the player class. See, it says public player, and it looks like a function, but it's slightly different. So notice that there's no return type here, and that's because it's assumed that the constructor is going to return you an object of the type of object that you're trying to create. So notice that the class here is called player, and the function name or the constructor is called player, right? So it is assumed that this player constructor is going to return us a player object. So constructors do not have to specify a return type. In fact, it's an error if you specify a return type. Then it would just be treated like a normal function. So constructors don't specify a return type. Also notice that we've made our constructor public. If we don't make it public, we're not going to be able to create this object using the new operator, right? So constructors are almost always public. And then also, let's say we wanted to have a player version of this where we passed in the name for the player. We could do that too. We could have multiple versions of this constructor that took different parameter lists. And I'll show you that when we get, I'm going to show you the rectangle constructors, and you'll see that. You'll see an example of that. So that's how you can spot that this is a constructor. It has the same name as the class that it's in, and there's no return type. So this is what we're going to use to create this object. So anything we want to do when we create this object, we're going to put it inside this constructor here. So what we can do is call our setup inventory function from our constructor. And that way, when somebody comes along and says, player P equals new player, what's going to happen is the constructor will get run, and then this function will get called, and the inventory will get set up. So constructors are places where you can do all the grunt work of setting up an object before somebody else tries to use it. So there we go. Now, it's worth mentioning, since this is your first time through this, that you never call a constructor directly. Like you'll never say, class player or p dot player. Like you're never going to use the dot operator on a constructor. You're always going to use constructors in conjunction with the new keyword, right? You're always going to say new and then the name of the constructor, right? So here's an example. Player P equals new player. That's the correct way to do it, right? There's the name of our constructor function, and there's the new keyword, right? We can't really do it the second thing here. Like we can't use our constructor like it's a function because there's no object attached to it. It just doesn't make any sense, right? So when you want to actually make an object and carve out a space for it from memory and initialize it, you want to use your constructor. And notice that it has the same name as the type, right? Constructors have the same name as their type. Okay, so let's take a look at how your program actually is organized in the computer's memory when it's running, right? So your program chunk has like three major pieces to it. So the first part is your code, right? The Microsoft intermediate language, right? That's the machine language that your code gets crunched down into, right? So the first chunk of your program in memory is going to be the code. And then there's two segments that are stuck on the end of that. And one of them is called the heap, and the other one is called the stack. So the heap is this kind of pool of memory that is used to create new objects. So when you create new objects, like let's say you've got a game and you've got missiles flying around or bullets flying around, every time you use the new operator, you're going to be using some memory out of this heap. And what happens is your variables all exist in the stack here, and what they do is they point to your objects in the heap. And I'm going to show you a picture of this in a second to kind of make it a little more obvious what's going on. And the reason I'm telling you all this is because I'm showing you this because there's common problems that people run into if they don't understand quite how this works. So this is the point of explaining how this works. So let's take a look at our program here. And let's assume that we're creating an object of type missile, and we're going to call it M. When we do this, we get a variable created for us in our stack, and it is set to null. It's not actually referencing an object, right? So all objects that we work with in C# are actually references to objects. They're not objects themselves. Like they point, it's like the address of an object that lives somewhere in the computer's memory. So when we do this, we haven't actually created a missile. We've created a reference to a missile, and that reference is set to null or 0. So if we tried to do something with our missile right now, our code would fail with a null pointer exception because missile has not actually been initialized. So what we now need to do is say missile M equals new missile, and we'll see what happens. So when we do that, a missile object is carved out of, some memory from the heap is taken, and it's converted into, it's initialized to be a missile object. The constructor is run, and then the location of that object is set in our variable right here. So our M variable now references the missile object in the heap, right? So you could see what would happen here if, it is possible to run out of heap space if you try to allocate too many objects, right? So the point is, until you use the new operator, this missile object doesn't actually exist. It's the calling of the new operator that carves out some memory from the heap, initializes it, and then goes back to your original variable, and then makes your original variable point to that new object, right? So by doing this, you don't get that null pointer exception. Okay, so there we go. I already said that, right? So let's just review some things that I just talked about. So constructors are just special functions. They have the same name as their class, and they're used to set up the variables to their initial states. They're frequently overloaded, and they don't specify return types. So because they don't have to, because a constructor is going to return you an object, the object you're trying to create. You don't have to specify a return type. Okay, so I'm just going to show you something real fast here. I'm going to pop over to Visual Studio, and I have a little program set up, and all it has is just a little picture box and a button. So when I click on the button, what I'm going to do is tell picture box 1 to redraw itself, or I'm going to tell it that it's been obscured and uncovered. That's what the invalidate does. And what then Visual Studio will recognize, or the program recognizes, hey, that picture box needs to get repainted. So this is going to trigger a repaint event on the picture box. So in the picture box, I'm just going to draw a rectangle on, or in the paint event, I'm just going to draw a rectangle on the picture box. So let's look at the rectangle object. So I'm going to make a rectangle R, and when I do this, I have created a reference to a rectangle. I've not actually created a rectangle. So if I now do let's see, e.graphics.fill rectangle, and I pass in, I don't know, brushes dot blue violet or something, and then R, and I run this, let's see what happens. You should be able to guess what happens. There are build errors. Okay. What doesn't it like about that? Unassigned local variable R. Oh, it's smart. Okay. It recognizes that this thing is null. It won't even let me compile. What if I just like force assign it to null? Cannot convert is a non-nullable type. Okay, interesting. So Visual Studio is smarter than I thought it was. So in order to actually make R point to a rectangle, I am going to use the new operator and then the word rectangle, right? Because a constructor has the same name as its class. And now what I can do is if I start this, you can see that there's 3 different ways to create a rectangle. Remember I was telling you that constructors are frequently overloaded? That means that there are multiple versions of those things. So I can create one using a point and a size. I can create one using 4 integers, an x, a y, and a width and a height. Or I can probably create one using 2 points. Oh, I don't know. Why is it not? It's not cooperating. Point size. Um, oh, or I can, or there's an empty one like that. Okay, so now what I can do is I can go in here and say 25, 25, 50, 50, and now this should be happy if I try to run it. And I click on there. Yeah, there's my rectangle. Okay, so um, the point is, when I've done this, I have not actually created a new rectangle. That object does not exist. R is null. The rectangle object does not exist until I type new rectangle, right? Until I use the constructor to actually create a new object in the heap, and so that this variable here can reference it. So that's why if you get a null pointer exception, you probably did something like this. Actually, what if I put R? If I do it up here, is it maybe, I'm going to try, I'm seeing how smart this thing actually is. Now if I run it, what happens? It should blow up at me. No? Okay. I don't know why. Well, anyway, there we go. Oh, it didn't. I don't think it even compiled. Okay, so there's the gist of constructors for you. You use them in conjunction with a new keyword to actually carve out an object from memory. Until you've done that, you've got a null object, and using a null object is going to result in your program crashing with a null pointer exception. So there you go. If you have any questions about constructors, just ask.